All right, there are a couple helpful tools that you can use for this part of the notes. We are going to be writing ionic formulas. Okay, so again, your formatting notes are up here. You can use those if you would like to do this on the computer, or you can write it out on your own paper if you would rather. All right, cations are positive ions. I've just got a plus sign there. They're positive ions, and anions, on the other hand, are negative ions. Anions are negative ions. So we've got different naming rules for whether they're positive or negative ions, and there are different types of positive ions and different types of negative ions. We're going to focus on the cations first, then we'll learn how to do anions. So cations, we've got two basic types. We've got monatomic cations. That means there's only one atom. Mono means one. Monatomic ion means one atom or one type of atom. And then we have polyatomic. Poly means, a lot of times it means many, but it really in this case just means more than one. So polyatomic means more than one type of atom. So it's at least two different elements involved in the positive side of the ion. And then we can break down the monatomic ions into two different groups. We're going to start with what we call fixed charge cations. These are the ones that are predictable. We always know their charge, and they're the easier ones to work with. So fixed charge cations. There's a little bit of memorization here. Group 1A ions always have a positive 1 charge. So the sodium ion is Na with a positive 1 charge. Or you could just write it Na+. Group 2A cations are always positive 2. Not too bad so far, right? Strontium ion, Sr, has a +2 charge because it's in group 2. Remember, the groups are the vertical columns. The aluminum ion, so those are the two groups, okay? Group 1A, Group 2A. We got a few others that we need to memorize. Aluminum ion is always positive 3. So it's always going to be Al3+. The zinc ion is always positive 2. It's Zn2+. And then the silver ion is always positive 1. Silver is Ag, positive 1. So those are the five things you kind of got to memorize, okay? And the first two are pretty simple because it's just the number. 1A cations are positive 1, 2A cations are positive 2. But then the other three, you kind of have to know where they're at on the periodic table to find a little bit of a tip. So if you find those on the periodic table, they kind of make this shape. Almost a staircase. And at the bottom of the staircase is Ag. And then we have Zn. And then we have Al. So it's really not so bad when you think about it that way. We have a positive 1, positive 2, positive 3 as you're climbing up that little staircase. And it's right over there in group 11, 12, and 13. But it's just those three elements in group 1 and group 2. Those are the ones we need to memorize their charges. All of the other metals, keep in mind this is specific, all of the other metals have a variable charge. That means it can change. So we need another piece of information to tell us what the charge is. That is written as a Roman numeral. So you want to get to know your Roman numerals, okay? Roman numeral 1 means positive 1. So Cu with a positive 1 charge. Manganese This is the Roman numeral for 2, so that would be Mn with a positive 2 charge. Iron with 3 I's is Fe plus 3. And then lead, and we have IV, that is Pb with a positive 4 charge. Then we get to chromium Vi, that is Cr with a positive 6 charge. All right, and those are our positive ions that are monatomic. Just one atom. They're all metals. It's either group 1A or 2A metals. It might be aluminum, zinc, or silver. Or it might be one of the other metals that's in the D block or in the F block, or that small little section of metals that are in the P block. But all other metals, other than the ones listed in that top box, we don't know their charge, so we have to give the Roman numeral, and the Roman numeral tells us what the charge is. The one polyatomic ion that we need to know for positive ions is ammonium, and I want you to go ahead and memorize ammonium. We will give you the chart of polyatomic ions so you can find it, but a lot of students will start looking all over the front of the periodic table looking for an element called ammonium, and you will not find it because ammonium is not an element. It's a polyatomic ion, NH4 with a positive 1 charge. NH4 plus is what ammonium is. I mentioned that polyatomic ion chart for the first time just now because most of them are negative. Let's look at the polyatomic ion chart. Here it is. There's some other helpful tips on here, but this is our polyatomic ion chart. You've got your anions, the negative ones here, and the cations. Since there's only one of them, it's listed up here. Okay. You can also find this on the back of the periodic table, but ammonium, it'll be given to you in some form that ammonium is NH4. You need to know how to use that fact, though. You need to know how to use it, and it's really useful to remember what it is so that you don't spend too much time looking for an element that doesn't exist. It's not an element, it's a polyatomic ion. Okay, so let's look at the anions. We're shifting gears, going over to the right column, and talking about negative ions now. Well, our negative ions, the way we name them is by using the root name. Like for hydrogen, it would be hydr. And then we put "ide" at the end. If it's a negative ion, it ends in "ide." If it's a negative monatomic ion, so just one element. So, in other words, we would have hydride. Let's just do a few of these. Hydride is what H would be. Carbide. And then for nitrogen, it would be nitride. And so on. Now let's look at how we decide what the charges are. Group 4A anions are always -4. So like carbide would be C with a -4 charge. If it's a group 4A anion, it's a -4 charge. If it's a group 5A anion, that's one further over to the right, and it's closer to the noble gases, so it has fewer electrons that it would have to gain to get to a full outer shell. And I can explain why later if you want me to. But instead of being -4, this is going to be a -3 charge. Group 5A has a -3 charge, so the nitride ion, for example, is nitrogen with a -3 charge. Group 6A anions are always -2. I hope you're kind of seeing the trend. We're counting down as we move to the right. Negative charges but we're counting down. Sulfide would be S with a -2 charge because it's in the 6A group. And then finally 7A anions are always going to be -1. Br- or Br-1 for bromide. You notice we did not mention group 8A. Remember, group 8A does not form ions. It is neutral. So group 8A doesn't get involved in ionic bonds. It's neutral. Then finally, if you have a polyatomic ion that is negative, we're going to consult the polyatomic ion list for anions, for polyatomic anions. There are a couple I think you should memorize. They are hydroxide is OH. Every year, this is one of them that students get wrong the most often. They think that hydroxide is just H with a -1, but that would be hydride. Remember, there is no X in hydrogen. So hydroxide is a polyatomic ion. It's OH with a -1 charge. And the other one is cyanide. You're not going to find it on the periodic table, so I recommend that you memorize cyanide. That's CN with a -1 charge. Again, you get to use the polyatomic ion list on the test, so you'll have the names given to you in a form that looks at least very similar to this table. Either this table or something very similar to it will be given on the test. But it's helpful to memorize a handful of these that we use a lot, and especially hydroxide and cyanide, because those are the most commonly messed up polyatomic ions, just from my past experience.